Hello everyone. Question is a retail company is operating its e-commerce application on AWS. The application runs on Amazon EC2 instances behind an application load balancer ALB. The company uses an Amazon RDS DB instance as the database backend. Amazon CloudFront is configured with one origin that points to the ALB. Static content is cached. Amazon Route 53 is used to host all public zones. After an update of the application, the ALB occasionally returns a 502 status code that is bad gateway error. The root cause is malformed HTTP headers that are returned to the ALB. The web page returns successfully when a solutions architect reloads the web page immediately after the error occurs. While the company is working on the problem, the solutions architect needs to provide a custom error page instead of the standard ALB error page to visitors. Which combination of steps will meet this requirement with the least amount of operational overhead? Choose two options. Option A. Create an Amazon S3 bucket. Configure the S3 bucket to host a static web page. Upload the custom error pages to Amazon S3. Option B. Create an Amazon CloudWatch alarm to invoke an AWS Lambda function if the ALB health check response target failed health checks is greater than 0. Configure the Lambda function to modify the forwarding rule at the ALB to point to a publicly accessible web server. Option C. Modify the existing Amazon Route 53 records by adding health checks. Configure a fallback target if the health check fails. Modify DNS records to point to a publicly accessible web page. Option D. Create an Amazon CloudWatch alarm to invoke an AWS Lambda function if the ALB health check response ELB.internal error is greater than 0. Configure the Lambda function to modify the forwarding rule at the ALB to point to a public accessible web server. Option E. Add a custom error response by configuring a CloudFront custom error page. Modify DNS records to point to a publicly accessible web page. Correct answer is option A and option E. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Question is a company wants to use a third-party software as a service SaaS application. The third-party SaaS application is consumed through several API calls. The third-party SaaS application also runs on AWS inside a VPC. The company will consume the third-party SaaS application from inside a VPC. The company has internal security policies that mandate the use of private connectivity that does not traverse the internet. No resources run in the company VPC are allowed to be accessed from outside the company's VPC. All permissions must conform to the principles of least privilege. Which solution meets these requirements? Option A. Create an AWS Private Link Interface VPC endpoint. Connect this endpoint to the endpoint service that the third-party SaaS application provides. Create a security group to limit the access to the endpoint. Associate the security group with the endpoint. Option B. Create an AWS site-to-site VPN connection between the third-party SaaS application and the company VPC. Configure network ACLs to limit access across the VPN tunnels. Option C. Create a VPC peering connection between the third-party SaaS application and the company VP. Update route tables by adding the needed routes for the peering connection. Option D. Create an AWS private link endpoint service. Ask the third-party SaaS provider to create an interface VPC endpoint for this endpoint service. Grant permissions for the endpoint service to the specific account of the third-party SaaS provider. Correct answer is option A. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe.